We're pleased to present this training webinar today on SPECIATE, EPA's repository of organic gas and particulate matter, chemical speciation profiles of air pollution sources. Today's training will provide an overview of EPA's SPECIATE database and how it is developed and used, summarize the updates made to SPECIATE in the recent versions, and show how one could use a speciation profile to compute species emissions. If you have a related science question during or after the presentation, please type it into the Q&A pod at any time. And once the presentation ends, we will answer as many questions as time allows. You can listen through your computer speakers, and EPA plans to post today's slides on our website within the next week, and the recording will also be posted within a few weeks. And I believe Aaron has typed that web address into the chat pod for you. Our presenters today are George Pouliot from EPA's Office of Research and Development and Art Diem from EPA's Office of Air, the Office of Air Quality Planning and Standards. George, I'm going to turn it over to you.
Hello. Can you hear me?
Yes, the volume's a little low.
Okay, now can you hear me well now?
Yes, thank you.
Okay, welcome to EPA's Tools and Resources webinar series. Today I'm going to talk about the SPECIATE database for about 20 or so minutes, and then Art's going to give us a little demonstration on how to use the publicly available browser to look at the database and to understand the information that's in it. What we'll cover today is in my presentation is what is SPECIATE, who works on it, and then talk about the uses and importance of the SPECIATE database, and then Art will go ahead and talk about the browser, how it's used to interface with the database. So SPECIATE is actually a Microsoft Access database that stores, it's a repository of all source-based speciation profiles that provide the chemical composition for organic gases such as VOCs and particulate matter, and for other pollutants such as mercury. Sources that we delineate or store in the database include things such as wildfires, household product usage, all sorts of oil and gas operations, and cooking such as charbroiling and frying, and road dust. Those are just a few examples, but there's hundreds more. This little diagram under here shows you how we typically speciate VOC, because VOC is what's measured in the inventory, and this database provides a way of breaking it apart into individual chemical compounds. VOC is shown here on the left. Example compounds are shown for PM2.5 in the middle, and for mercury they're shown there on the right. The reason we have this database is that we want to make the best available scientific information about organic gas, PM, and other pollutants speciation profile data. The data can come from the EPA or from state agencies or from peer-reviewed literature and other relevant data sources. We also provide additional metadata elements useful for anyone using the data. But examples of the metadata that we might include would be a short description of the category, simple like wildfires or oil and gas production, the weight percent of an individual compound, the test method that was used, the year that the measurement was taken, the test reference method, and also the actual, if it's peer-reviewed literature, it would be the reference links to the actual reference where the data came. This is SPECIATE is a cross-office collaborative organization, a group of team, and it's led by ORD, OAR, which is Office of Air and Radiation, and also OTAC, which is the Office of Transportation Air Quality. We meet twice a month to discuss profile priorities, data availability, resource planning, and contract management. And here you see a list of all the members of the work group. in speciate. The primary uses of the speciate is for air quality modeling. All kinds of air quality modeling applications, such as regulatory modeling applications, where we need to test new sector and transport type rules to test air quality standards in the present and future. It's also used in developing new versions of the model and updating existing treatments within the model. For example, we're working on improving the secondary organic aerosol treatment in the CMAC model, and part of that improvement involves updating speciate. New chemical mechanisms used in air quality modeling, if they are developed, we need to take the information in the speciate database and make it compatible with any new chemical mechanism. Also, if you're interested in doing a specific sector analysis, and this information will be very helpful in tracking down the individual compounds that we would be modeling from that sector. Such sectors might be volatile chemical products or the oil and gas sector. It's also helpful in assessments and health studies, such as the National Air Toxics Assessment, because it helps us determine amounts of specific compounds that are in the hazardous air pollutants inventory. Other uses of the speciate database would be to estimate black carbon. Black carbon is also known as elemental carbon in the database, and we track elemental carbon for every source that's in there. And it was used for the EPA's black carbon report to Congress. And there's a link in there actually that you can click on. You can get that report that was done several years back. It's also used in source apportionment, used in estimating air toxics emissions, and other countries have used our database in speciate for their PM and VOC speciation needs. Speciate is a workhorse for air quality models. It's every single model run, the data that goes into it was derived using speciate in one form or another, both for domestic and international modeling efforts. Over 1,000 research and policy planning institutes have published, and they've cited the speciate database. And states will use the speciate database in their air quality modeling for their state implementation plans. This diagram shows us a historical how speciate's been developed over the years, going back to 2002 when we had version 3.2. We're up to 5.1, which was released in July of 2020. And it's a cumulative update, so every update includes all the previous profiles plus new ones. And this shows you how we've added new profiles over the years to the database. The color codes show you the type of profile. The orange is the PM profiles, both PM2.5 and PM10. And the blue are VOC gases, and the other represent things such as mercury profiles that have been added over time. As of version 5.1, which was released this year, there were 6,746 profiles. And between 5.0 and 5.1, we added 16 gas profiles, 18 profiles for PM2.5, and 58 mercury profiles. The profiles used in our current modeling platform for 2017 are shown here. This tells you what version of speciate the profile was originally introduced. As you can see, we're using profiles from all versions, but a large number from one of the earlier versions of 3.2, but we continue to use new profiles. We mapped all the profiles that are in the database, not all used by the modeling platform. Only about 475 profiles are used in the platform. 387 are VOC and 88 PM2.5. And as you see, most of them are still from the original version. The process of adding data to the speciate is a process that we work on an ongoing basis. It's systematic. We start by either tracking literature or we know about other sources of data. We check the data for completeness. We develop profiles, making sure that the information is complete, and we may even sometimes consult with the authors of papers to verify information or if we have any questions. When we're finished at that stage, we actually compute what's a quality score on the profile to kind of give a overall trying to create a numerical code value that helps us understand the quality of that particular profile. We enter in the database. We check the database. One example that we use for states is that we can get oil and gas exploration and production speciation data is often available for a specific basin within a state. So we need to have each state would have a different set of profiles related to that part of their state. This is a flow chart kind of explaining how the process works. We bring in new information. Either we have a database of priority needs that we know where our most important sources that we need profiles from, and so we use that as to guide our literature search. We screen the literature for useful information that could be made into a profile. If we don't see any speciation data in the literature review, we don't use it. But if we do find sufficient data, we are able to build a workbook that includes all the calculations that are used. Then we review the workbook, assign a quality score, which I'll get to later on how that works, and then we put it in the database. And then periodically, after we collect a number of profiles, we release the database in different versions. This 5.1 was released in 2020, and the previous one was 5.0 in 2019. So they're sometimes 1 year apart, but they could be maybe 2 or 3 years apart, as you would have seen in the earlier slide. So we have there's a couple of papers recently published on the priority needs that we need for the speciate database. So this paper here by Casey, Bray, and others systematically went through all the profiles to determine which ones we need to update and which ones are good and within our modeling platform. And from that work, we determined there was essentially 4 major areas where we need to improve our profiles: residential wood combustion, non-road equipment, all types of fires, and then also oil and gas exploration, production, and all the parts therein. So we also have to take those profiles and match them to specific source classification codes, which are the way we track individual sources in the National Emissions Inventory, or the NEI. One of the things that we've introduced in Speciate starting in 5.0 is the Q-score process, where we try to rank profiles to help us guide which ones to use in modeling. An ideal Q-score would have 30 points. That's if it's a profile based on measurements. Some profiles are not directly from measurements. They may be composites of measurements or from other methods. And the Q-score on that is a maximum of 29 points. But either way, we rank them. If they're in the 22 to 30 points, they're considered excellent. And then the other categories you can see there. And we put that code into the database so you can compare profiles in a quick and easy way. And we create a Q-score for every profile via a team discussion. We also have developed in version 5.1 is a guideline for data developers. We provide a documentation that helps a researcher to voluntarily develop their data in a way that can go easily to speciate. And this really saves time on our end. If you provide us data that's ready to go, then if it's already prepared and complete, we will be able to release it quicker and have more profiles in the database. This document is available online. It tells you how to develop your data, and it provides a template. And we also have a special email address set up for questions, comments, or collaboration requests. It's email is speciate_WG, that's speciate_WG at EPA.gov. And we monitor that email box regularly to let people to communicate with people on this topic. So since July of 2019 to July of 2020, we've added 370 new gas profiles. Well, actually, 370 new were added in 5.0 and 16 new were added in 5.1. So now we have a total of 2,561 VOC profiles. We've added new PM profiles. We've added a whole set of mercury profiles in version 5.1 that goes into what we call the other profile category. And some of these profiles are set up to use what's called the volatility basis set option within CMAC, and it's a way of accounting for the different types of volatility of emissions. Sometimes some sources are semi-volatile, intermediate volatility, so it's like a continuum between particles and gases. For some examples of the new profiles that we've added in as of 5.1 is sugarcane burning in the VOC category, many profiles for consumer products. We corrected a heavy-duty diesel profile, and we've added many profiles for the oil and gas sector. For PM2.5, we've added wildfires. Again, we've added a PM2.5 for sugarcane, and also for natural gas combustion in aircraft. And finally, we've added a whole group of mercury profiles for, we codify existing profiles for coal combustion, other sources from the UN's Global Atmospheric Mercury Assessment Program. We've added new profiles for geothermal power and cement kilns. One thing that comes up when we talk about VOCs is the terminology known as VOC and TOG. Well, VOC is a subset of TOG, so you also could view it as TOG being a superset, larger than VOC. So all VOCs are TOG, but not, there's compounds that are part of TOG that are not a part of VOC. Because TOG includes all organic gases, includes compounds of carbon, except for carbon monoxide, carbon dioxide, and these inorganic types of carbon. So what we need to do is VOC has a regulatory definition that you can get, that I'll get to on the next slide. It basically includes things that have high volatility, whereas TOG can include all types of volatility. And we have a factor that helps us convert when the inventory people measure VOCs, but our modeling requires TOG, so we need to scale up VOCs to TOG, and we use a VOC to TOG conversion factor. So to determine what compounds are considered VOCs, most volatile organic compounds are VOCs, except for what are listed in this Federal Register. And specific compounds that are excluded are ones that are exempt, which have been determined not to have any impact on photochemical reactivity. But they include such things as methane, ethane, methylene chloride, and a whole group of compounds that I can't show here because it would be screen upon screen of them. But anyway, they include certain classes of pure perfluorocarbon compounds. If you go to the Federal Register, you can get a full detailed set of information about that. So, like I mentioned earlier, when you want to model, your model wants TOG, but we only inventory VOC. So what we need to do is have this TOG to VOC ratio, which is always greater than or equal to 1. So basically, it's a factor that when you multiply your VOC by, it will give you a larger number, so that it accounts for the mass difference between the two. And here's the formula, one of the formulas you can use to calculate that ratio. This is already computed in the database for all of the profiles in there, so it's available for your use. And one of the things you'll find out is the sum of profile weight percent should add to 100%. There's some exceptions, but by and large, they add up to 100%. Here's an example of a speciation profile that you can query in the database. This is a very simple profile that I use because it only has four compounds in it: ethane, formaldehyde, methane, and propane. And it's an uncontrolled natural gas flare that goes back to 1989. But the weight percents are very easy, 30, 20, 20, and 30, so that adds up to 100%. And you see that methane and ethane are 50% of it, so that the VOC to TOG factor is going to be 2 to 1, and that's what you see here in this calculation. So if you wanted to find the mass of propane using this profile, you would get it, for example, for 100 pounds of VOC, you would multiply it by the 30% weight percent times the VOC to TOG factor, which is 2 to 1, and that would give you the 60 pounds of propane. Simple example there. We also have developed as part of the SPECIATE database is a quick QLIC type based browser application, so you don't need to dig into Microsoft Access, you can actually go to your handy-dandy web browser, and you can go in there and pick out any profile that we have in the database and view it and create instant graphics with it. And you can sort by weight %. You can look up species field names. You can also use go by CAS numbers or numbers used in computational toxicology. And you can actually compare two profiles and visualize them on the fly. And Diem is going to give us a little demonstration of that in just a moment. This is our contact information, so I'm going to turn it over to Art now, who's going to give us a demonstration how that browser works with the database.
I will go over the live demonstration of the SPECIATE website and data browser. To get here, the easiest way is just to Google EPA SPECIATE, and that will get you right here. Of course, you can download the Access database, and that's right here. We have our archived versions of the database. But going to the browser, you'll just hit this tab right here, and things will load right up. It takes a couple minutes. And I'll just briefly go over some of the navigational aspects first here. You want to pull the bottom of the pane into view so you can get to this slider here. The sliders going left and right and up and down are a little bit thin and a little hard to navigate, so you'll be going back and forth between your browser scroll bar and this slider a lot. You'll get used to it after a few tries. Another aspect is for each of these tables, you can sort any field by clicking on the field heading, and you can toggle between ascending and descending just by clicking again. You can resize the field, so if you want to see what it's saying, or if you want to minimize it, you can do that. And you can also rearrange the field, so you can change the order to make it easier to look through things. Okay, so another aspect, a great aspect, is the filtering. So you can filter on a field by clicking on the magnifying glass, and that brings up a filter menu. You can either click on an item that you want and hit the green checkbox, and that will show all your filters will be lined up on the top bar right here. And you can hit undo or clear. And so you can pretty flexible on how to set up your filters. So in the menu, anything that's a light color background is an available option. Anything that's grayed out has been filtered out. And of course, anything that's green is something that's been selected. So that's basically how to navigate. So let's go over some of the content of the SPECIATE database. This first page, the profile detail, this is your richest data table. This has pretty much all the fields that you'll want to use to find the profiles that you're interested in. So we have profile name, profile code, whether it's a gas or a particulate matter, profile type. We have these categories which are very helpful and useful in finding the profiles that you're looking for, from the generation mechanism of the emissions to the equipment to kind of what sort of fuel use. We have region. Region is a very flexible field. It could be a country, it could be a state, it could be a basin of a resource. Size range, those are very valuable for some of your PM profiles to know what kind of size ranges we're talking about, whether you're 2.5 microns and smaller or 10 microns and smaller. And then we have species fields. So we have CAS, numbers, species name, and also another very useful field is species names, which includes not just the primary name, but if there are any synonyms for that particular compound. And of course, here's a big, this is the big piece of information, the weight percentage of that species for a particular profile. We have a lot of other fields here. A big one that is important is included in some. This is particularly important for some of the particulate matter profiles where you might have some species that are overlapping, for example, chloride ion and a chlorine atom. So this is something you might want to click on to get everything to go to 100%. We define whether the species is has this air pollutant or HAP or not. We have molecular weights. Here's a great field, non-VOC TOG. So if it's yes, it is not a VOC. If it's no, it is a VOC. And I'll demonstrate that field a little bit later. And here are some of the more species properties, including the CompTox dashboard identifier for the species. And if you go into the CompTox dashboard, you'll get a lot of physiochemical properties of that particular compound. So we'll skip over some of these. Oh, here's some of the Q scores that George was talking about for profiles in version 5.0 or later. We have some other rating scores here as far as quality, judgment rating, vintage, how much data was used to generate that profile, testing years, and some other notes on the profiles and test methods. And going all the way to the right here, we have the link to documents and the links to the references. So you can click on one of these links and it will bring you right to the reference that was used to generate that profile. Okay, so that's the first tab. The second tab is Profile Basic. This is basically a pared down version of all the information that's in here. So you'll see at the bottom, you'll see a total of the profile code count. This is all the different profiles. So this is the 6,746 profiles we have in the database. And as you filter things out, this number will change. So there's more than these records in here. So if you have a profile that has 10 different species, that will have 10 different records in this table. So we also have a third sheet here, this profile list. All the fields here are on the first tab. However, for profile list, we have one record per profile. So you could have one profile. This doesn't go into the species that are within that profile, but this is if you want a list of profiles and go through those. This is there's a little bit of advantage of using this. Species properties. Most of these are included on the first tab, but it's sometimes easier to come in here and filter things on the species property. One great aspect of the click tool, which I forgot to mention, the filter is active across all 4 of these tabs simultaneously. So if you filter on one tab, that filter is active on the other. So the last 3 pages here are the weight percentage bar and pie charts. Those will give you an opportunity to visually look at the speciation profiles and the different species within them. The last, and I'll do a demonstration on that. The last one is just a historical list of all the changes that have been entered into the SPECIATE database since 2006. and it's there in case you feel like searching through that. So I've gone over the navigation and the contents of the SPECIATE database browser. I think now we'll go through a couple examples of finding and selecting a few profiles to look at and to compare those in the bar and pie charts. So the first example I'd like to pull together are some of the new oil and gas profiles that have been entered into version 5.1. So what I'll do is I'll go over here to the version. I'll type in 5.1. You can either type it in or you can select it from the list. Make sure you hit the green check afterwards. Okay, so now we've gone from 6,000 some odd profiles down to 91. So we'll go to category level 2, and we will hit oil and gas. We'll hit the tanks and wells. We'll look there, and we'll go through the profile names. Let's look at some of these flash gas profiles. So I can hit flash gas, and if you hit enter, it will select all the available ones with that. So we will do that. Yes. Okay, very good. All right, so now I'm going to go back up here. The category of the profile. Oops, I think I undid a filter. We'll go back over here. Make sure we hit version 5.1. Okay. So we have 14 here. Let's go ahead and take a look at these. So here in the bar chart, if you mouse over the profile code, we'll give you some summary information. One feature that we're going to add is to have the profile name shown in here. But you can mouse over any of these stacked bars and see the species name and the percentage for each of these profiles. So these are all TOG profiles, or total organic gas profiles. We can look at, we see we've got some methane and ethane in here. So we can look at what the VOC speciation of these are by clicking on species properties and going on to the non-VOC TOG field, and we're going to hit no. So no is going to be all the VOC. And once that is filtered, we can go back here, and the top bar here shows the total. So these are the total VOC speciation percentages within those TOG profiles. And this is going to be the inverse of your TOG to VOC ratio that George was mentioning in the presentation. So you see a lot of alkanes in here, straight chain alkanes, propane, normal butane, normal pentane. So we can also take a look at what the speciation of these profiles are. You can go back to the species property, go back to the field, apps, and pick yes. And then we can go back to the weight percentages. And you can see some of these profiles are a little bit different, and they do vary across. And you can use this information to figure out, okay, are these profiles ones that are like the sources that you are interested in? Okay, so that's the first example. I will clear this filter. The second example I'd like to go over are some of the new mercury profiles that we put in. So we will go to version 5.1. Hit the check. Go to the master pollutant, that's mercury. And we can say fuel product, let's pick some bituminous coal. And then we can go to the equipment. Let's use just the conventional boilers. We'll exclude the IGCC. We'll exclude cyclonic and stoker-fired boilers. And so here we go. We got 11 profiles here. If we go to the weight percentage bar, you can see that the mercury profile speciates into elemental reactive gas phase mercury, or otherwise known as divalent mercury, and particulate mercury. And the thing that distinguishes each of these profiles is the air pollution control configuration of these boilers. So if you have a boiler, you know the air pollution configuration. Let's say it's a cold side ESP only. You can look at one of these and you can speciate total mercury. And the modeling efforts will give different fate and transport for each of these species, and there are different toxicities, so that really matters. One couple other features and functions of the click tool I'd like to go over is there's the ability to export the data. So any set of filter data that you have, you can export. Unfortunately, this feature is broken on the server side, and our click developers are on the case, and within a few weeks, we should have that function back up and running again. So that pretty much concludes my introduction to the browser. I hope this was helpful in showing you how to navigate the system and how some of the content and fields that you might want to look at. So that concludes the live demonstration.